Okay, so we'll get this one started. Like I said, I don't know that we're going to go through and do the entire thing, but I want to at least get it started so you guys can understand. I think this was a simulation that I found, but it takes so long to complete, which is why we don't complete it. Inside of your favorite cereal box is a figurine of a famous sports athlete. The company claims that 11% of boxes contain David Ortiz, 27% contain Serena Williams, and 62% contain Tom Brady. A friend claims that he got all three figurines in 3 straight boxes. Let's run a simulation to see how many boxes it takes to get all 3 figurines. So I think what they really were asking here, and I'm going to put as the state, okay? The state, how likely is it to get 3 figurines, I think probably unique, 3 unique figurines in 3 straight boxes. Okay, I think that's really what they were getting at. This is incomplete. Okay, so now we want to do the plan. Well, whenever it's percentages, it's kind of easy. Okay, I'm going to show you the easy way to do it when it's percentages. It said 11% was Ortiz, so it said David Ortiz is 11%, and Serena Williams is 62%, and Tom Brady is 30. Oh, I'm sorry, I messed that up. Serena Williams is 27%, and Tom Brady is 62%. Okay, so whenever it's percents, we don't want to use 100. We don't use 3 digits. We want to make it 2 digits because, as I told you, and I'll show you in a second, the fewer digits you can make your labels, the better. So for David Ortiz, I'm going to say that's going to be 0, 0 to 10. Okay, because that is 11. That would cover 11. And then the next ones are going to be 11 to, we want this to be 27, so we'd add 27 to this, or actually 26, right? Because that includes one of them. So it would be 11 to 37. That's going to be 27 of them. If you counted that out, you'd see that's 27. So therefore, what's left, because it's 100%, we have to use all 2-digit numbers, use all of the 2-digit numbers. Then this is going to be 38 to 99 is going to be Tom Brady. Okay? So we don't have to worry about ignoring repeats because it's a percent. Whenever it's percent, you don't have to worry about repeats. It will cover everything. It'll cover from 0, 0 to 99, which is all the possible outcomes. So what are we going to do? We are going to look at double-digit numbers. Double-digit numbers. Okay, that's what we're doing with our table. And record what we get. A trial will end when we get 3 unique figurines. Okay, which means I get 1 Ortiz, 1 Serena Williams, and 1 Tom Brady. So the do part is where we run our trials. So we run our trials. Now the way that we're going to do this is we're going to use Table D. Okay, so we're going to go into Table D, and you can be following along at home in case you can't see this. Okay, because I'm going to have to pull this up. And I'm going to write down what I see here. 2-digit numbers. So line from line 101, so that you're telling people where you're getting your numbers from. I get 19, 22, 39. 19, 22, 39. Those are the first 3 numbers. 19, 22, and 39. You probably can't see that. 19 is Serena Williams. 22 is Serena Williams, and 39 is Tom Brady. Okay, so if I'm looking to see how many of these, I want to try to get them in 3 straight boxes. Well, here's 3 straight boxes, and I get 1 Serena Williams, or 2 Serena Williams, excuse me, and 1 Tom Brady. So there's 1 trial. Let's do the next 3 boxes. So the next 3 boxes, I stopped with 39. So I have 50, 34, and 5. 50, 34, and 5. 50 is Tom Brady. 34 is Serena Williams. And 5 is David Ortiz. Okay? So to get all 3, okay, to get all 3 figures in 3 straight boxes, it happened here. I got it 1 out of 2 times. Okay, so now we got to keep going. You can't say, well, I ran a simulation 2 times and this is going to happen 50% of the time. No, probably not. Okay, so let's do a couple more simulations, a couple more trials. Okay, this whole thing is a simulation. So I stopped at 0.5. So the next one is 75, 62, 87. 75, 62, 87. 75 is Brady, 62 is Brady, and this is Brady. So that was unsuccessful. So we were unsuccessful in our first one, we were successful in our second trial, we were unsuccessful in our third trial. So 87 was the last one. Next one is going to be 1396. 1396, I know those are 2 different ones, and 40. 1396 and 40. So let's see what 13 is. 13 is Serena Williams, 96 is Brady, and 40 is Brady. So we didn't get it there. So our last one was 40, okay? 91, 25, 31. 91, 25, 31. Let's look. 91, Brady. 25, Serena Williams. 31, Serena Williams. Didn't work. So how many simulations do we do? 1, 2, 3, 4, 5. We've done 5 simulations. Normally on a quiz or a test you would do 5 or 10 simulations because you can't keep doing this for the rest of your life. So if we were going to finish this, we would say, according to our how likely is it to get 3 figurines in 3 straight boxes, we would say, you know, we ran the simulation 5 times. This would be your conclude. You ran the simulation 5 times, and I found that 1 out of 5 times, or 20% of the time, we came up with 3 figurines in 3 straight boxes. Okay? Again, it's too small a sample size. 5, doing it 5 trials. No, you know you need more than that. But I just wanted to show you guys an example of how to do it. Okay? We're going to come back to this table D. We are going to come back to it. Okay? Because we have another example to do. So let's look. So this says Dylan is an 80% free. Come on, he's not an 80% free throw shooter. I find that hard to believe. Hard to believe. You guys tell me. Maybe he is. Maybe he is. Dylan is an 80% free throw shooter. How likely would it be for Dylan to go to the line 5 times and miss 3 or more shots? So let's see if we can set this one up, and we'll come up with our state plan, do and conclude. So what I'm going to do is have you guys pause this and see what you can do. See how you guys can set that up. All right, give it a pause. Okay, so hopefully you paused that. So our state, how likely is it, or would it be, for Dylan to go to the line 5 times and miss 3 or more? How likely is that? So it matters how we want to do this. If we're using table D again, this one's going to be even easier for us. Okay? So let's think about this. He's an 80% free throw shooter, right? So that means Dylan makes 80% of his free throws. Okay? So I think I can do this with one digit. All right? So let's think about this. So let's let 0 to 7 be a make or a made free throw, and let's make 8 and 9 be a miss. Okay? So 0 through 7 is a make, that's 8 numbers, and then here's 9 and here's 10, here's the 20% he misses, here's the 80% he makes. Okay? We are going to look at table D, beginning on line 101, and record 5 one-digit numbers. Again, we don't have to, because it's percent, we don't have to worry about repeats. Okay, so we're going to look at 5 one-digit numbers and count how many. So let's think. How many times he misses 3 or more. Okay, hopefully that makes sense to you guys. So we're going to take 5 one-digit numbers in table D, and we're going to count of those 5 how many times he misses 3 or more. Okay, because that's what we're trying to find out here. Okay, so our do are going to be our trials. So let me grab that table D again. Be easier for you guys to see in your own books right now, but that's okay. Do my best here. Do my best. So let's write down the first 5 numbers. Here we go. 1, 9, 2, 2, 3. So I write down 1, 9, 2, 2, 3. So 0 to 7 is a make. So this is a make. Let's do a check mark for a make. That's a make. 9 is a miss. 2 is a make. 2 is a make. 3 is a make. How many times he misses 3 or more? Did he miss 3 or more here? No. That's our first simulation. Let's look at our next one. 95034. 95034. So we have 1 miss there, and the rest are makes. So didn't pass in that trial. Next one. 05756. 05756. Make. He did not miss 3 or 5 there. 28713. 28713. We got 1 miss there, but it still was not 3 or more times. here we go. 96409. 96409. Well, guess what? We got 2 misses there, but it still doesn't qualify because we want to know how likely is it for him to go to the line 5 times and miss 3 or more. Have you guys been at a basketball game when Dylan's gone to the line 5 times and missed 3 or more? I want to say I have. 12531. 12531. All makes. Make. 1, 2, 3, 4, 5, 6. We'll do a few more. 42544. 42544. Nope. Those are all makes. 82853. 82853. Nope. There's only 2. There's 2 that he missed, but it's not 3 or more. Excuse me. So that's 1, 2, 3, 4, 5, 6, 7, 8. Let's do 2 more. I did that one already. 73676. 73676. Nope. No misses there. Last one. 47150. 47150. Nope. So our conclude here, we would say something like, we ran a simulation with 10 trials and came up with 0 times where he missed 3 or more. Therefore, this is not likely to happen. Something like that. Okay? Something like that. 0% of the time, you can't say it's never going to happen. I don't know. Andrew, Keith, you guys tell me. Real life, what's going to happen? Is that going to happen? I don't know. All right? So that's how you do a percentage simulation. At that time there, guys, we did the whole thing, didn't we? All right, stratified sampling. Suppose I want to choose a simple random sample of size 6 from a group of 60 seniors and 30 juniors. To do this, I write a person's name on an equally sized piece of paper and mix them up in a large grocery bag. Just as I'm about to select the first name, a thoughtful student suggests that I should try to stratify by class. I agree and decide to be appropriate to select 4 seniors and 2 juniors. However, since I already mixed the names, I don't want to have to separate them all again. Instead, I will select names one at a time from the bag until I get 4 seniors and 2 juniors. This means, however, that I may need to select more than 6 names, design and carry out a simulation using Table D to estimate the probability that you must draw 8 or more names to get 4 seniors and 2 juniors. Okay, so this is what we're charged with. So let's see if we can set this up. All right, so what do we have? State plan, do and conclude. State. What is the probability that we must draw 8 or more names to get 4 seniors and 2 juniors? What is that probability? So let's do the plan. So for the plan, there's, how many seniors are there? There's 60 seniors and there's 30 juniors. So I have to account for that. So I am going to say 0, 1, or not 0, 1. Well, we could do 0, 1. Or I'm going to do 0, 0. 0, 0 to 59. And that's going to represent the seniors. Okay, that's 60 because it's 0, and then 1 to 59 is 59. So that's going to be my seniors. And then I'm going to say 60 to, what's that, 30? So 60 to 89 would be juniors. Okay, and then this isn't a percent one, so we can't just leave it at that. We have to say what happens if we draw numbers 90 to 99. Okay, so if you draw 90 to 99, we are going to tell people to ignore that. Okay, so what are we going to do? We are going to select 2-digit numbers until we get 4 seniors and 2 juniors. That's our process, right? And then we will go back and then we'll take a look at it and we'll say, all right, so once we've done that, how many times did it take us to accomplish that? So let's do the do part. Okay, so again, you're going to use your, should we use a calculator for this one? We could. Let's do the calculator for this one. Okay. So this is how you use the calculator for it. We use Table D a bunch of times, and I'm hoping that makes sense. On the first quiz, I think they have you use a table. and they give you the table. So let's do, what is it? It's under math, I think. And then we go down to probability.